So one thing I wanted to go over is the process of actually clocking a gas meter. If you go outside to wherever your gas meter is, depends on your location and your state and the utility company, but usually it's on the outside of the house. Might be in your basement, might be somewhere else, but most oftentimes it's outside on a corner or by the street. If you look on the front of it, it's this thing called an ERT, and it's this component with a bunch of dials on it. Okay, and that is what they use to read your meter visually. And what you can use also to see the amount of gas being flown through that meter. And how it tracks is it spins these dials. These dials will spin based off the usage. Okay, they'll be spinning, spinning, and spinning. And the speed of how they're spinning depends on the flow rate. Okay, and this is all cubic feet of natural gas. So that is a 1 by 1 by 1 box of gas. So think of it this: if you have this thing spinning and it does 2 revolutions, this half-foot dial. If it spins twice, that is a 1 by 1 by 1 box of natural gas that's just flowing through your meter. And what we're doing is seeing how fast the flow is, the flow rate. And we do that by counting the time it takes to get one full revolution. Okay, there's some nuances in doing this. The important thing is you see which way it turns. Okay, and that little dial, you want to catch it on the upswing, preferably around probably the 4 o'clock on the upswing. You'll notice they have some backlash. So if they're falling, or if they're around dead center right here on the bottom dead center, they'll have some backlash and some play in them. So you want to catch it on the up, so that on the upswing, so that you don't have any play and you get an accurate measurement. So what you'll do is you'll start a timer from when it gets to this point, and you'll count the time it takes and stop when it comes back one full circle. And that is the time it takes for a half foot, and then you would do the same. You could do the same for any of these. Preferably the smaller, it's easier. You could do a 2 foot as well, the time it takes for a 2 foot, and then times that by your correction factor of 2. But that's how it's done. It's very simple. Get out there, time it again. If you're unsure about your measurement, time it a third time. But you want to get it on the upswing, preferably around this 4 o'clock position. So that's no play in that ERT.
All right, so now we're moving on to our furnace section. We're going to go and ensure that our furnace is getting the right BTUs. So to do that, we're going to clock a meter and then our outlet to our valve to make sure everything's correct. So we're going to go ahead and remove the outlet port, which is located on my gas valve right back here. So now we can put our port from our manometer on. And I got this fitting here to do that, so I'm going to slip this on. Okay, nice and snug. Alright, so our port is now on, installed. And at this point, we can hook up our manometer. Our tester is getting pressure from that port. We're going to hook it right to the gas valve right there, so we're nice and stable. That's a nice little magnet feature. So now we're going to go ahead and change from cooling to heating, and we're going to go clock our gas meter outside. So we now have our meter being clocked right now, and the goal is to catch that ERT, that dial, on the upswing. So by that means is you want that small half-foot dial, you want that on the upswing. So that means about the 4 o'clock position, 4 or 5 o'clock, and that is our lap right there. That took us 28 seconds, 29 seconds for a half cubic foot. So now we'll punch that into a calculation and we'll get our cubic foot per hour, CFH.
So one of the things I did for the clocking the gas meter is made a meter cheat sheet. So here is the approximate BTU value. I think it was, we're going to go like 1025. So here was the time it took to complete one revolution of a half cubic foot dial. It took 28.94 seconds. We can round that up to like, what, 29. Get a little bit bigger of an answer. So with 29 seconds per revolution on a half-inch dial, my BTU per hour was 63.62 or 63,620 BTUs. Well, I have a 60K BTU furnace. So what does that tell you? That tells you we're a little overfired and we have a little bit too much gas going through there. So what I'm going to do is check the pressure at the outlet of that gas valve. And we're going to dial it back a little bit. Then we'll have to re-clock our meter. This is like, you don't just do it once and you're done, and you just, rule of thumb, go a little bit at a time and see where you land. 3,000 or 4,000 BTU, and that could be 1 inch or 0.01 or 0.1 inch of water column. So we'll make an adjustment and see how it reflects to get our seconds per revolution. What you want, if you're overfired, you want it to take longer for a full revolution. If you are overfired, you want it to take longer than your last reading. If you're underfired, you want it to take less to get one revolution.
Hot surface igniter, just glue. All right, we got initial fire. We're gonna go take a peek and see what we're getting. 3.8, that's pretty high. 3.87, so we're way overfired. We're gonna go to 3.5. So to do that, we're gonna adjust this screw here. Let's grab a flathead screwdriver. Okay. Flathead screwdriver. Oh, well. There we go. Finally, flathead screwdriver. Okay. And we are going to, ever so slightly, break that loose. Okay. Thread this guy off. Now we have access to that adjustment port. You can probably see it now. There's that adjustment port right there. So now we can actually adjust that. And how we're going to do that is we're going to get our little flathead screwdriver once again and dial back that pressure. So I'm going to turn counterclockwise and you're going to watch that manifold pressure drop. We're going to see what this looks like with 3.5 inches water column. A little bit more back. Small adjustments. It's like ever so slightly. Okay, so now we're going to put the cap on and then we're going to test it. So you want to put the cap on, it will affect it just ever so slightly. It's like a TXV set screw. There's that little cap on top. I've seen it where you get a few degrees different of superheat with and without that cover on. Might be hard if we're going to do that with one hand, so I'm going to put this back on my chest rig. Okay, we're going to do this with two hands because that's difficult. Okay. We're going to tighten it down just so slightly. And now we're going to run outside. We're going to go clock that meter once again. I know it sounds tedious, but clock it again. Don't ever just leave it. Okay, there we go. See how we changed a little bit? 3.48, 3.49. All right, let's go ahead and go outside and see what we get. Okay, we started on our upswing. We're going to see how long it takes to get this dial to do one full revolution on the upswing. See how it stutters a little bit at the bottom? That's what you want it on the upswing. So that way you know it's not going to stutter.
So our original BTU per hour was 63,000, just under 64. I adjusted to 3.5 inches water column and ended up being 58, so a little underfired. So what we're going to do is adjust it to 3.55 inches water column. Now let's just check the difference between the two. We're going to test this one at 3.6 inches water column. And we're going to see what we get. So I just took kind of like if it was linear, if every, 0.01 was some value, I would get this if I made a change of 0.1. So we're gonna just go off that theory, and we're gonna go clock it again and get our next rate. But on the second one, I got 31.76. Our target is 60,000. So we can do some quick math, but I think it'll be 31, roughly 31. It'll be 30.6, I think.
All right, we got our startup of ignition sequence. Draft motor's on. We've proven draft with a pressure switch. HSI is on. We'll have our trial of ignition. Okay, flame sense. All right, so right now we got 3.6. 3.6. Okay, we're gonna clock this again.
After some time of adjusting, ending up at 3.62 inches of water column for the outlet of that gas valve. The final BTU ended up being 59,893, which that is very close to my 60,000 input for this furnace. Keep in mind our input is not going to be the output. We're going to take this value. We're 80% roughly. So this will be my output. I mean, close to 48,000, which is nameplate, very close to nameplate. So I would say this is good. Might be a little underfired, but not by much. I mean, you can sit here all day and adjust it, and that gas pressure may float just a little bit here and there. So this is close. This is good. Better than overfired. I'd rather be a little under than over. All right. So now that we have found our inlet BTU per hour, we can use that to find our CFM. There are two variables that you can use to find your CFM, or two variables you need to plug in, I should say. We are using our input BTU from our last calculation, rounded up. And we are also using our delta T, which is our temporize. We're getting that right now. So our inlet is 70 degrees and our outlet is 92. We want to see our airflow based off of our temporize. But if you're questioning it, what you need to do is verify with the nameplate, and that would be at the furnace. That should be just below the model and serial, somewhere on the nameplate. You'll find that value. All right, well, it's starting to get warm in here, so we're just gonna go ahead and take our total temperize now. Took my inlet and my outlet, subtracted my outlet from my inlet, or vice versa, to get my delta T. Plugging that into this calculation, and both to get the CFM, we can move some things around, do some basic algebra, and see that CFM is equal to your BTUs divided by your temperize times a coefficient or a factor of 1.08, and that'll get you your CFM, which in this case is really, really high for CFM. But I mean, our temperize was within value, so that doesn't matter. For my Goodman, it's 20 to 50. So 30 is right in the happy place. You can go a little bit more. If you want a higher temperize, you might feel a little bit more comfy. But for what it matters, this is right on spec, so it doesn't matter for me. So to review all the things that we've went over, we started with clocking our meter at whatever dial we choose. That could be a quarter, half, 1, 2, whatever the dial size is on that ERT on your natural gas meter. You find the time it takes for one revolution, input it to a standard calculation. In my case, I've put these values into a formula, and then times that by your natural gas BTUs per cubic foot. For my area, it's about 1025. On any given day, it might be a little different, but consult what your area is running at. You can use the data from last year if you don't know off the top of your head. Otherwise, contact your local utility company, and they will let you know. Then you can get your BTUH, which is your BTUs per hour. This value, it's very important, this value should match what your furnace nameplate says. If it doesn't, then make adjustments to your gas valve input or your output from your gas valve. That goes without saying. You need to do this again after you do that. If you're not on point, if you're not close enough, if you're overfired, go ahead and decrease that manifold pressure. I started at 3.84, bump it down, see what it's at. If you go too far, bump it up. And every time, clock the meter again, clock the meter again. It only takes a few minutes, it's a little bit more steps up and down an attic, but you're giving value to yourself, and you can stand by what you're saying. You can speak knowledgeably of what you're doing. So always clock that meter for gas. You can't just say, oh well, I always set it to 3.3 inches of water column, and that's what gets me by. No, you could have the wrong orifice. So always clock that meter and see what you're putting into that thing. Your input will tell you a lot. Okay, so once we found our input, then you can calculate your output roughly. There are some tools to better do this, but for me, I did 80% furnace, so I took my input times 0.8. I got my output, which is 47,914. Really close to nameplate. Nameplate is 48K. So, this looks good. All right, and then we can find our temperize by running our furnace. Get your outlet minus your inlet. That'll be your delta. Plug that into your calculator, and you can calculate your CFM. Biggest thing, you don't really care about CFM all that much in heating mode. You really just care about your temperize. Is it within spec? Was it going to go out? You can fine tune stuff for CFM, but biggest thing is temperize. For me, it's 20 to 50. For you, it could be 40 to 70. These things all depend on your manufacturer of your furnace. So consult that, read the manual, and go from there.